All right, let's get started with the exciting topic of security. Well, it's not really all that exciting. It's not exciting, and then it gets exciting, right, when something bad happens, and we want to avoid the excitement. So let's talk about how we do that. So almost all breaches are preventable, 93%. And so let's talk about how we prevent them. And first of all, right, we're trying to protect from a lot of different things, right? Former employees, curiosity seekers, so many databases, like, you know, the employee leaves and they leave the password in place that the employee knew and they can get in. And then obviously there's a lot of different ways that folks can get in, and I'm not going to belabor this too much because it's a very short session. Right, and they can get in through various aspects, right? We can steal the data at a file system level. We can get into the database itself. We can sniff the network, although that's less common now that SSL is on everywhere. But there's all sorts of things that we're trying to prevent. And the attacks come in forms of like SQL injection, right? Very common. Buffer overflows, don't hear about those as much anymore, but they can certainly happen. Insider abuse, like I was discussing. And there are things we can do with all of these things, right? Brute force, network, eavesdropping, malware, yada, 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 right? There's things we can do to make sure that these attacks aren't successful. And using the tool that are in MySQL. And, right, we don't want any of these bad things happening, right? So what do we have, right? So we've got, in MySQL, we've got a lot of different things, right? So, you know, if we start over here, right, at the end user side, right, we've got network encryption. So everything's encrypted by default, right, through TLS. And it's encrypted everywhere, whether it's between the user and MySQL or MySQL and other MySQL databases and all this HA stuff, right? And we have a thread pool, right, so we can sort of minimize attacks, right? So people talk about that in the way about performance optimization, but it's also a way to minimize how many connections can hit your server. On the authentication side, right, it's important to note that, right, way up there, I don't know where this thing is pointing, but right, we can do external authentication, and a lot of attacks happen because of lack of proper user management of database accounts, and especially DBA and powerful accounts. Right, so we can do that. Masking and de-identification, I'll talk about that more. We have a firewall that works quite well, so we can firewall the SQL coming in. So this is like grants on steroids, right? Because we're really training the firewall what we're going to allow. Cryptography, right, is great until it's not great. And when it's not great is when the keys aren't managed quite well. And developers especially are bad about managing keys, managing other sorts of secrets. And so we have a key vault, we have a key ring inside of MySQL, and you can even put your own secret information onto that key ring, and it'll get stored in a key vault. And you know, there's key vaults from various vendors, right? We have Oracle Key Vault, there's, you know, Thales, Gemalto, all these different vendors have those sorts of things. That key ends up going so that all our data at rest gets encrypted, right? So whether it's table space files or bin logs or redo logs, or even now configuration information can be pushed onto the key ring so that it's not available. Backups, right, are key, and a lot of data has been stolen by people stealing the backup, right? They leave the backup unprotected. You just grab the backup or store it somewhere else, you got the whole database. And then finally, auditing, as far as, you know, let's watch and see what's going on. So this log, everything. And we have a really powerful engine there where you can specify exactly what you want to watch and not. Because, like, for example, I wrote the DISA STIG, the Department of Defense and Government Guidelines for Security. And they say log everything. But then I talk to them and they're like, yeah, well, you can't really log everything. You fill up the whole disk, right? So when we added these filters, it really increased the adoption of this, because before it was kind of like all or nothing. Now you can watch exactly what's going on. So that sort of sets what we got. So passwords, the worst threat of all of them, right? Almost every breach started with a weak password or a password that somebody knew that used to work for you, right, and they didn't change it, those sorts of things. And so there are ways around this, right? So one is that we have what's called the MySQL Enterprise Authentication. And so instead of having an account that you do create user on every single database instance or cluster of databases or whatever, right? It's really better to manage them maybe through some central thing like an LDAP server or your Active Directory. So we can do that. On the passwords, if you end up needing to have a password, right, we have password policies. So, and right now the policies really should be that they should be quite long, right? So the old 8 with all these complex characters, nobody can remember that crap. Excuse my French, but nobody can remember the password. So really what we want is we want longer, and you go past about 12 or 14 and these rainbow tables and things are just brute force attacks, can't reverse engineer a password. We now have multi-factor authentication, so now you can have, say, a password and then your YubiKey, or you could combine a local password with your LDAP password, or any combination of what you want to do, you can do there. And then finally, we have an X509, right? So you can sort of have this identification through certificates of who the person is to the server, and the server can validate themselves back, right? So you can do a combination of those. And so when we went to MySQL 8.0, we went to a SHA-2 with 5,000 rounds, and a lot of people are sending it to 10,000 now. These things are meant to be really, really slow. And so, but MySQL, people like connect, disconnect, really, really fast, right? And so if your authentication is going through that every time, it's really slow. So we did what's called the caching SHA-2, which basically means we'll do these 5 or 10,000 rounds, whatever you happen to put in there. But then within a certain period of time, if it's disconnected and then it reconnects again, we can recognize the hash that's coming in and very, very quickly authenticate it. So your PHP apps or your microservices that are constantly connecting and disconnecting work really well. Another cool thing to do, and some of the financial companies we work with do this, is Kerberos. And so, Kerberos is a token system, and so, and you can, like when you log into Linux or when you log into Windows, right, Active Directory is Kerberos. On Linux, you do use what's called a GSAPI API to get the token information. It's on Windows, you can use either the SSPI or GSAPI. We actually support both. But what we have some customers doing is that they have functionally driven grants of tokens for certain tasks. And the nice thing about Kerberos tokens or any others is that they expire. They have a time to live. And so even if you do steal it, it's not going to be any good for all that long. And so these things work out quite well, and we have a lot of the financial institutions doing that. And you can do that either directly with a native KDC, or you can do it with a LDAP service or Active Directory service. We do have Windows-only AD, although quite honestly, with a few exceptions, you have to run the MySQL server on Windows. We do have one major customer that runs thousands of Windows servers with MySQL, but everybody really runs Linux 99.99% of the time. And our LDAP thing will talk to your Active Directory server. And then finally, so there's a thing called FIDO2. It's an alliance of a lot of financial institutions. And what FIDO2 is a way to generically support YubiKeys, thumbprint readers, all those sorts of things. And so we include the FIDO2 U2F, and the FIDO2 WebAuthn is coming out in a month, or it's either in April or July. And so this allows you to have two-factor with a biometric or something like that. And we do support the Linux PAM interface, but quite honestly, it's pretty clunky, and there's some, I don't recommend it anymore. And the LDAP one is actually very, very fast. So, so I think it's really better to centralize. And so when you look at it, right, this is sort of what the whole thing looks like. So you've got your LDAP director there, you've got CA certificates here, validating the server. You've got your KDC that if you're doing Kerberos, and again, you can combine it across any of these for your authentication here. And again, if you've got a DBA that's working across 100 databases, you don't have to create 100 accounts. You create a mapping to your LDAP DBA group, and then it all works. And again, we've got the largest credit card company in the world, I think, running this across an LDAP directory of 400,000 employees, right? So this thing is working at scale. We've got the largest bank in the world that's doing Kerberos across currently 5,000 servers, and at some point it'll probably be 20,000 MySQL servers, right? So you don't want to manage local accounts at that scale. It's a bad idea. So, so again, passwords, at the application level, they're hard to manage. Don't put them in clear text. Don't do it. But if you do have them and you do use them, you got to rotate them often. And there's a feature that Booking.com encourages us to do that they use that works quite well that I'll describe in a bit. Kerberos tokens are great. Certificates are great. The hostname stuff used to be a lot more valuable, but right now it's not so much because these things change too much, and with VPNs and things like that, So I would say be more concerned about the user and the way they authenticate than relying on the MySQL at hostname type stuff. But obviously, like with root and things like that, try to just limit it to localhost. Obviously, want to limit grants. We have roles now. Also, another thing that a lot of people maybe not realize is that a role, so when you define a role for a user in MySQL, or multiple roles, you define a default role, and then you can define other roles, and based on what the user's doing, you can actually change the role. And so say this is an application user, then you can escalate privileges or de-escalate privileges by changing the role of the user, right? And so this way, say somebody is doing a SQL injection attack, if by default the role is set low and they don't know that it exists, right? It's unlikely they're going to go, set role to this other thing in their injection and try to get that through there. All right. So on password management, right, so I know and a lot of times for DBA it's hard to shift into these universal LDAP Active Directory. It's not stuff DBAs know. So the other thing we have is what's called dual password change. So the problem is when you change, if you just change the password and you don't instantaneously change the password across all your application microservices that are going to MySQL using it, right, the connection is going to fail. So what we implemented is that you can have a dual password. So you can add a new password, right, and you can retain the current password. And then, right, you can distribute the new password out, give it some time. I don't know, hours, minutes, whatever it takes. And then you can discard the old password. And so, that way you can see what's going on. And I think there is also a way to see if the old password's being used. I can't remember the command off the top of my head, though. So files, they get attacked, and you want to encrypt them. Now, in MySQL database service on OCI, obviously everything's encrypted at rest. But again, you can take a table space or a file that is for a table and import it somewhere else, right? They're transportable. You can get to the data. So you want to encrypt that data. And so you really should put, we put these keys on a key ring that's inside a memory. So the key is never, it's never on the file system. It's only on this OKV or Gemalto or HashiCorp or OCI Vault or AWS Vault, right? It's there, not persisted. When the system starts up, it pulls the key, so it's not sitting and reading the key back and forth constantly, right? It gets it, it holds it, and then when you rotate it, right, it'll rotate it back. Oftentimes, too, on these key servers, I don't know if I mentioned it, but often on these key servers, you don't have one. Usually you have 3 or 2, 3. In the case of like this one major bank, right, they have 3 data centers. For failovers, they have 9. So we can support up to 9 IPs for the key server, and that way, if you lose a data center or whatever. So it's that cluster thing where you have to have 3 to have a vote and all that. So we actually support up to 64, but 9 is really the magic number. And again, it's very easy. So once you enable the key management, then you just tell us what you want to encrypt. So you can encrypt individual tables, you can encrypt all the tables, you can encrypt the redo and undo logs. When we first came out with it, we only did table spaces. The majority of your data that somebody could steal is in table space files, right? So, okay, if they steal the bin log and it's not encrypted, well, they'll get some data, but they won't get 10 million rows, they might get 1,000 rows, right? So it's up to you, but we can encrypt all of them if needed, depending on how sensitive the data is. Auditing, again, trust but verify. It's important to turn this on. We can also do certain forensic analysis, all sorts of things. We actually feed some of this into some machine learning type of things, so you can do anomaly detection. Again, you can determine what goes in the thing. You can actually also decimate the actual user data. Decimate's not the right word, but obfuscate the actual user data, insert statements and things like that with this. So that if you just want to see, okay, what was the statement, how many times did it run, you can do that, versus actually having a social security number or something like that exposed in your audit log. And so, yeah, the workflow is you install it, so it's just install plugin, audit, you call a create filter with some JSON that defines what you want to audit, and then you bind it to which users you want to be audited. So the firewall is an interesting one. So this firewall is actually inside. So a lot of people used to rely on monitoring unencrypted connections coming into the MySQL to look at the data coming in and stuff like that, and then throw alerts. Well, that's kind of crazy because you should just encrypt all the network stuff. And so because of that, right, the data comes into the database, but now our firewall is inside the database, right? And it's an allow list based firewall. And so you really cannot get past this thing. And this thing can scale up. We have a bank in Eastern Europe running 400,000 patterns that they match on the whitelist that they have. And so it would be hard for you to create that list on your own, right? And so the way it works is that you install it, you turn it into, you put it in allow mode, and you say learn. It learns all the whitelists, and then you can decide whether you want to block things or just detect them and write them to a log, right? So often I say put it in learning mode, then switch it into alert mode, see if you're getting any false rejects in there that really should be okay. If you don't, then put it in block mode. If you do, then you probably need to let it learn a little bit longer. Okay, so de-authentication, right? It's important to be able to de-identify data, so we have some tools for that. And so we have the basic sort of things like string masking. We have a dictionary-based replacement, so that's like tokenization or whatever. So if you see secret agent, replace it with secretary or something, right? Something different if you want to sort of do replacement such that maybe a developer can use the data or something like that. And then we have specific masks for SSN and for payment card. And payment card is probably one of the more popular ones that gets used. And this one is LUN compliant. There's a couple of different modes you can use on that. And so, right, typical type of things, substring masking, Social Security masking, payment card masking, replacement based. And the replacement base works on basically a dictionary that you create that has the if this, then this type of replacement, or you can randomly pick things from it. And then finally, so how do you mask numeric type stuff? Well, we can do randomization and generate ranges of values on data if you need to do that, right? So if you want to sort of obfuscate, for example, here the salaries of certain levels of employees, but you still need to sort of do some massaging on it, you can do that sort of thing. So, and I'm probably going too fast. I don't usually. So you need to run MySQL security assessments, right? You need to upgrade and patch. This is where it's nice if you have high availability, right? So as Kenny was talking earlier, right, you can upgrade a secondary, shift it to a primary, and go through and never have any downtime. Also have to remember that some of the major things that have been announced out there have not been bugs in MySQL, but bugs to the development frameworks and the ORMs on top of it that maybe didn't do proper data type checking or things like that where people could do a SQL injection on them. And so, the whole stack really needs to be up to date. And application libraries. Also, like for example on OpenSSL when there was that big issue with it, right? So MySQL 8.0 is completely dynamically linked to the shared library for OpenSSL. And so the case would be that you would simply have to upgrade OpenSSL, bounce MySQL, it picks up the new library, and you're patched. In the past, you would have had to wait for us to go in and statically link all this, replace MySQL, upgrade everything. You would be vulnerable for a period of time that would take for us to do it because we would have to wait on OpenSSL to do the fix and all that sort of thing. So yeah, it's much better this way. So you need to check and recheck, and I'll talk about that a bit more. Monitor, review, change, watch suspect activity, review the application code, right? Make sure, in particular on applications, it's data type checking, and I would say that it's especially important if you can prepare your statements. Then what the difference between prepared and non-prepared from a security standpoint is that when you prepare, then the statement is sent separate from the data. If you don't prepare, what really happens is even if you're using bindings, the data and the bind data get created into a statement that gets sent down to the server. And so if that bind data gets tainted with SQL injection type of strings and you're not checking it out, then you can still have SQL injection with the current way that we work if the data is not prepared. So it's good to prepare data. So I know there's certain cases where it doesn't make sense, but if you're not doing it, then make sure you really have good checking on your data types before they go in to the MySQL statement. Let's see. Also, I worked with the Center for Internet Security for a year, writing recommendations for how you should go in and harden your server. And so these typically explain, or the way that they are is that we've got 100 and something rules, and it explains, okay, here's a risk that you have. Here's how you go check. Here's the SQL to run to see if you've got this risk in your database. And then, okay, we found the risk, what do you need to do? So then it's the remediation for the risk is written up. So, set persists, require secure connections, for example. We'll make sure all connections are encrypted or they won't take them. So all these sorts of things are there. And a lot of these recommendations are referenced within regulatory requirements that you might get for your company, right? So by following the CIS standard, then you may, or you're much more likely to sort of hit some of these things that you might need on a regulatory standpoint. Now, the other one that I also worked on, this is what you do when COVID is going and you write a lot at home. So I worked on the Department of Information Security, or the Information Security Agent Secure Technical Implementation Guideline, right? So if you're working with the DoD or the VA or any of these things, then they have their own specification of, given the type of data that you're storing in a MySQL database, what you need to do to harden it. And so, you have to, obviously, if you're working with and even if you're a contractor to a Department of Defense, you have to follow these guidelines. So this has got 132 of these SRGs in it. And again, it's very similar to the CIS, the Internet Security one, other than the fact that it's a bit more specific. But both of these are free, they're out there. They're for MySQL Enterprise Edition 8.0. The older version of the CIS one, the 5.7.1, was really, we didn't write it, and it was pretty minimal. This one's really much stronger, as is this. Also, right, when you get MySQL from us, right, versus some fork or whatever, right, there's actually a huge difference. And so we have very strict security practices as far as how we do updates, how we alert our customers, bulletins, handling things. We go through all sorts of scanners for the code, static scanners, dynamic scanners. We have people trying to hack MySQL from another team and things like that. And occasionally they'll find something that we go in and repair. And then the employees that we have working on it, right, are certified. So some of the other forks of MySQL and stuff like that, you don't really know who's in the code, right? And so that things happen, right? Code gets altered and stuff like that. But if you're getting it from us, it's totally certified, identified, and all that type of stuff. And we go through all kinds of SecArc and various reviews of everything we have. It's painful, but it's a very good thing, right? So you know that this stuff is good, and then obviously we do a lot of testing, and we publish these security guides. So these are important things to know that you've got. And if you want to sort of look at the details of how we do all that, that's where they are. And so, okay. All right, well then I timed it perfectly. I guess, are there any questions?